What is a dipole?
Sir, I'm not exactly sure of the exact definition, but
Di means what?
so there's two charges, right, which are equal and
Yes,
they have
equal in magnitude,
opposite polarity.
opposite polarity. Very good. So what is a dipole? Dipole is equal in magnitude, opposite in polarity, is called dipole. Let's say one charge is plus q, another charge is minus q, and they are separated by a very small distance, let's say 2a or r also you can write. Then they form a dipole. So two charges, they are separated by a very small distance, they form a dipole. Now, what is the direction of the dipole? The direction of the dipole is from minus charge to plus charge. Okay, Tanisha. So we are finding out, we will find out the dipole, the electric field due to a dipole on the axis and on the equator. Are you clear, all of you? So what we are finding out? We'll find out the electric field. So how it is different from the previous case? Previous case, electric field we have found out for a single charge. What was the formula? What was the formula? Formula for a single charge. A charge is there. In the surrounding, there will be field. Right? In the surrounding, there will be field. And at a distance r from the charge, what is the field? Equal to kq by r square. This is field for a single charge. Now, how the dipole is special from this single charge? A dipole is two charge, combination of two charge. Dipole is combination of two charge. So two charges are there. That's why the formula will not be same as a single charge. The formula will be modified because two charge combined effect will come. Okay, two charge combined effect will come. So here we are calculating the dipole on the axis. This is the axis of the dipole, and this is the equator of the dipole. So this is called equatorial, line, and this is called axial. So this question comes many times in the exam. Again and again, I'm saying this dipole case. If you look back your previous 5-10 years question paper, board of question paper, this dipole will be every year there will be question from dipole, either derivation, numerical, maximum time the derivation comes, the dipole. So once we do it, you just practice it 2-3 times, and without looking at the notebook, you should be able to derive it. I'm just following this derivation is completely as per your NCERT. So once I complete, you go through the book and try to make the diagram and the derivation as clearly possible as given in NCERT. So we are now let us derive it, and let us derive it first. Okay, so first let us derive equatorial case. What is the meaning of equatorial case? Equatorial means what? We'll find out. We'll find out. Yes.
So how is the first diagram, the axial and the equatorial, different from each other?
Axial is on the axis. Suppose two charges there. This is the axis of the dipole. So we are finding out. We are interested to finding out. We'll be interested to find out the electric field on the axis somewhere here. This is the axis case. Axis means suppose line which is passing through both the charges. This is axis. Okay.
So this is
This
for the first case.
axial.
Axial one. Okay.
Yes. Yes, Tanisha.
Nothing, so the equatorial one.
Equatorial one is two charges are there. Now this is the axis. Now make a perpendicular. Draw a 90-degree here. Okay. And bisect it perpendicular 90-degree. So on this perpendicular bisector, any point over it, this is called equatorial line, which is perpendicular bisector. Are you getting? Making 90-degree. This line is called equatorial. So we will find out electric field due to both the charges, not single charge. Single charge hota to ye formula ban jata. This formula would have been. You can easily write this formula. But this is not the single charge. This is due to both the charges. So we'll find out electric field here, 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 any point on the equator. And the first case is any point on the axis. Clear all of you? Both of you?
Yes, sir.
Okay. Now, we'll derive it. First, let us derive the case of equator. So two charges, one is plus Q, another is minus Q, separated by a two small distance, let's say 2a, they form a dipole. Now we'll find out electric field on the equator. So we'll make a perpendicular bisector, join it, and this is a equatorial line. Now let us find out at any point P. This is any point P, and we'll find out the electric field here at this point E. We'll find out the electric field at this point E. Okay. So due to this plus Q charge, the electric field will be what? Away or towards? The electric field will be away or towards?
Towards.
Plus charge. Plus charge. For a plus charge, the field lines, for a plus charge, what I told you in the previous slide, for a plus charge, what is the field lines? How the field lines look like for a plus charge?
Away from the charge.
Away from the charge. Okay, away from the charge. Barshit, are you noting down or not? So note it down along with
Yes,
the.
sir.
So note down the important points. So this is the point where we're interested to find out the. So this is plus Q charge. The plus Q charge, the field at point P will be away. The direction will be, the arrow mark will be away. This will be the electric field due to plus Q charge. What about minus Q charge? Minus Q charge, the field lines will be towards the minus Q charge. So this will be the electric field vector E minus Q. Are you getting? E minus Q. Now we'll find out the resultant of these two vectors. Because two vectors are there. I have told you in the first class, Tanisha, the vectors are important in class 11. If two vectors are there, let's say A and B, this is, let's say, A and B. If the angle between them is theta, right? then what will be the resultant vector? We can make a parallelogram. This one will be the resultant. So what will be the resultant? What will be the resultant? Now A magnitude square plus B magnitude square plus 2A B magnitude cos theta. Right? Root over. Clear all of you? If two vectors are there, any vector, maybe electric field, maybe force, maybe any type of vector, if they are acting on a point and they are making theta angle with each other, then what will be the resultant vector? Are you getting? Can you correlate with parallelogram law here? Yes, Tanisha.
Yes, sir.
In the first class, I have told you about parallelogram law, right?
Yes, sir.
So here we are using parallelogram law. Parallelogram law is if two vectors are there acting, making an angle theta angle between them, and they are at a point, acting at a point. So what will be the resultant vector? A square plus B square plus 2AB cos theta. So here also same situation. Same situation. Wow, same situation. This is E plus Q. This is E minus Q. And we'll see that E plus Q magnitude and E minus Q magnitude same. They are both the vectors. Right? They are vectors. So both vectors. The angle between them is, let's say, if this is theta, this is theta, this angle will be 2 theta. Are you convinced? In a triangle in class 7, 8, you know that sum of exterior angle is equal to sum of interior angle. So theta equal to x plus y. You know this theorem? Yes or no? The exterior angle is equal to sum of the interior angle. Yes or no? Basit.
Yes, sir.
So here, why it will be theta theta again? Because both are, this is a perpendicular bisector. So we know that isosceles triangle, if two sides are equal, so the perpendicular bisector, it will passes through the perpendicular bisector. Okay, and if both the sides are equal, both the angles also will be equal. This theorem also we know. So that's why here both the sides are equal, isosceles triangle, so both the angle will be equal. So if it is theta theta, so it will be 2 theta, theta plus theta 2 theta. So now angle between the two vectors is 2 theta. Okay. So what will be their resultant? A resultant we can write resultant vector. Also, I have told you another theorem for your parallelogram law. Parallelogram law, if two vectors are same magnitude, I don't know if you remember or not, if two vectors are of same magnitude, let's say A and B. If two vectors are of same magnitude, let's say A and B. Okay. Two vectors let's say A and B, and if B magnitude and A magnitude are same, then their resultant vector will bisect the angle between them. That means if this is theta, full angle is theta, so this resultant will make theta by 2 and theta by 2. So here we'll see that the E plus Q magnitude and E minus Q, E plus Q magnitude and E minus Q magnitude are same. So they will basically divide the angle between them. They will basically divide the angle between them. Okay, so it will become, this angle will become theta and this will become theta. Try to understand carefully. If this is theta, E plus Q, what will be the component of E plus Q on this vector? Who will say? Varshit. If this is plus Q, this is minus Q, what will be the component of this vector on vector on this resultant? That is the E net electric field. Now, if you remember the vector resolution, how to resolve a vector. Suppose this is axis. Now this is suppose a vector, and it makes an angle theta. So what will be the component of a vector along x-axis? What will be the component of a vector along x-axis?
A cos theta.
A cos theta, very good. This will be a cos theta. And component along y-axis is a sin theta. Clear? So E plus Q on this, if this is theta angle, total 2 theta, now the resultant is dividing it theta. So this is theta, this is your E plus Q. So what will be the E plus Q component all here? E plus Q cos theta. Are you clear? And E minus Q also, this is theta. What will be component on this E net? E minus Q cos theta. Are you clear?
So could you draw another diagram? This is getting a bit crowded.
It's already, many things are there. Okay. It's looking bad now. So two charges are there. Distance between them 2a. Okay. Perpendicular bisector, we are interested to find out the electric field on this perpendicular bisector. Let's say at a point P, we are interested to find out electric field, and this is, let's say, plus Q charge, this is minus Q charge. Due to this plus Q charge, the field will be E plus Q, which will be away, error mark will be away. And due to minus Q charge, the electric field will be towards, this will be E minus Q. Okay, this is E plus Q, this is E minus Q. Now, if this is, both the sides are equal, so if this angle is theta, this angle will also be theta. So this total angle will be 2 theta. Now we can say that E plus Q magnitude and E minus Q magnitude are same because they are at the same distance. This distance and this distance is same. That's why E minus Q and E plus Q magnitude will be same. If two vectors are having same magnitude, then their resultant will bisect it. So this is the resultant vector that I'm writing E net, let's say net electric field. So it will bisect. That means it will be theta, this will be theta, total 2 theta. Clear, all of you? Now E plus Q will have a component along this axis. So we can write E plus Q cos theta. And E minus Q also will have a component here. Suppose this is a coordinate axis. Okay. A vector is here, a vector, and this is theta. What will be a vector component along x-axis? A cos theta also. If this is a vector, What will be the A vector component along x-axis if it's theta? This will be also a cos theta. Are you getting? Okay. So this will be also cos theta. Now, if this is E minus Q, E plus Q, so E plus Q cos theta will be there, and E minus Q cos theta also will be there on E net. E minus Q cos theta also will be there. Right? Electric field due to minus Q charge, that is E minus Q, and it is cos theta. So what will be the net electric field? So net electric field will be the sum of these two electric fields, that E plus Q cos theta and E minus Q cos theta. Are you getting? So what will be the net electric field? Net electric field will be E net is E plus Q cos theta plus E minus Q cos theta. Clear? Now, what will be E plus Q cos theta? E plus Q cos theta, you can see that distance, and E minus Q cos theta, both are same distance. So E plus Q and E minus Q magnitude wise same, cos theta cos theta. So I can write 2 times of E plus Q cos theta. Both are same, x plus x 2x. I can write, right? Now you see E net is 2. What will be E plus Q? That will be K. What will be E plus Q? K, or you can write simply 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. K, 1 by 4 pi epsilon naught plus Q, or Q by R square. What will be R here? This length, distance from here to here. Are you getting? The field we are supposed to find out the field at point P. Our charge is here. So what is the distance? This is the distance. So how will you find this distance? Now, the distance between minus Q and plus Q is 2a. So what will be half distance? This is a, this is a. Let's say the perpendicular distance is r. So what will be this distance? Can you say? What will be this distance? This is r. This is a. What will be this distance? Like a right angle triangle. Suppose this is a right angle triangle. This is your A. This is your R. What you can write this one? Hypotenuse. This is our distance between the charge and the point P, right? This is point P. This is our charge Q. So this is the distance. Can you say what will be the distance? What's it?
Sir, I'm not sure.
In a right angle triangle, if you know two sides, then how will you get the third side?
Oh, Pythagoras theorem.
Pythagoras theorem. So how, this is also right angle triangle, right? This distance is R, this distance is A. So what will be this distance? Using Pythagoras theorem.
R square plus A square.
R square plus, very good. R square plus A square root over. right?
Yes, sir.
So this is the distance. So what is the formula? E plus Q. E plus Q formula is what? KQ by R square, right? 2 is 2 there. E what we can write? KQ by R square. K is 1 by 4 pi epsilon naught. Q ho gaya. What will be R here? R square. R square will be R square plus A square root over whole square. Are you getting? With cos theta. Kanisha,
Yes, sir.
are you getting the mathematics?
So I'm having a bit problem with the R square that you did. Which charge are you taking as the reference point for this?
This point P is at a distance R from the midpoint. So we have taken this R distance. A is the distance midpoint of this Q and minus Q. Q and minus Q distance is 2A. So midpoint will be A. Now this is forming a right angle triangle. So this distance, the diagonal, your hypotenuse will be R square plus A square root over Pythagoras theorem.
Why are we putting the distance of PQ?
Why are you putting the distance P?
Pn plus Q.
And plus Q. Because we are finding out electric field at point P. So electric field at point P, P is at distance from Q. What is the distance? Suppose this is your plus Q charge and here is your P point. So if I'll ask you what is the distance between Q and P, so will you go by this way or will you go by this way? What will be the distance if I say what will be the distance between P and plus Q? That I have to use in the formula, right? That KQ by R square. R will be my here. This one is my R distance. Not this, not this.
Okay, sir.
Are you getting? The straight line I
Yes, sir.
required, minimum distance I have to find out. Which is the minimum distance? This one is the minimum distance between P and plus Q, right?
Yes, sir.
Getting?
Yes, sir.
Right. So that's why we have taken, and that is that we do not know what is this. So we have to use Pythagoras theorem to get some relation between A and R. That's why we have done it A square plus R square. Because we need, this is the distance our R between Q and the point P. So similarly for this side also, that's why it become 2 times. Okay. KQ by R square. R is our R square plus R square, A square root over. Clear? Now here we'll also replace cos theta. If we replace cos theta, look at the diagram and tell me what will be the cos theta. This is our triangle. This one is A. This one is R. This is A. And this one is R square plus A square root over. Now this is theta. This is your theta, right? So what will be cos theta here? What is cos theta? What is cos theta here? Cos theta is what? It's P by B or B by H or B by H? What is that?
B by H.
B by H. So what is base here? Base is the side
A
that by R square
root
plus
over R square plus A square.
cos theta. Clear?
Yes, sir.
Now E net will write in more precise form, you replacing these values for cos theta. So cos theta will replace, that is 2Q by 4 pi epsilon naught Acha, r square a square whole square root over whole square means root over will be there removed. A root whole square is what? A root over will be removed. You know this, right? So r square a
Yes,
square
sir.
root over whole square will be r square plus a square only. And what will be cos theta now you told? That is a by r square plus a square root over I can write power half. Yes or no? Same.
Yes, sir.
Root a means a to the power half. Same, right? So I can write r square plus a square half. Now you can multiply and tell what will be our E net. What is our E net? Total electric field. In the numerator 2qa. In the denominator, what is there? 4 pi epsilon naught. Acha, r square plus a square power is nothing means 1. R square plus a square power is half. If I will combine this, what I'll get? If I'll combine this, what I'll get? Can you tell? Marcel? In the denominator, here is r square plus a square. Here is r square plus a square to the power half. If I'll combine them, what I'll write? What I'll write? What I'll write if I combine them? Can anyone say? It's like in the denominator, suppose you consider this one the x. So suppose x into x to the power half. What will be the result? X into x to the power half. What will be the result? X into x to the power half. What will be the result? Tell me. What will be x into x half? If base is same, what will happen to power? If base is same, what will happen to power? Power will be
You
added, you know this
can add it, sir.
1 plus half. It x to the power 3 by 2, right? So here also same, r square plus a square power 1. Here r square plus a square power half. So if I'll add, so I'll get r square plus a square to the power 3 by 2. Clear? Just you try, it's exactly written in the NCERT. You go through it, derive once this question again and again. I'm saying 3 to 5 marks question will come 100% in the board exam. Okay, so you practice 2-3 times. If you'll get any doubts, you will ask in the next class. So this is the E net, that is 2qa by 4 pi epsilon naught r square plus a square 3/2. Now, last approximation also will do that. The definition of dipole, we have told you that the distance between the two charges is very small. The distance between the two charges is very small. Very small. That's why your R is very, very greater than A. R बहुत बड़ा है A से. So R बहुत बड़ा है A से, इसीलिए हम क्या कर सकते हैं? What we can do? Now R square is very big as compared to A square, so we can neglect A square. Like if R square is suppose 1000 and A square is let's say 0.1, so your result will be 1000.1. So result is not changing very much. That's why we can neglect this 0.1, approximately 0. So A square will approximate to 0. So what E net we are getting? Net electric field at point P, we are getting 2qa by 4 pi epsilon naught. This one A square will be 0. R square to the power 3/2 will be R cube. This is your net electric field. Clear? Because this one A square is 0. Are you getting this last step mathematics? If A square is 0, what is there in the denominator? R square whole to the power 3/2. Power to the power, if it is there, then what you do? Multiply. So 2 into 3/2, 2 cancelled out, it will become R cube. Are you getting? Okay. So many things are there. You just practice it and try to go through it slowly. If required, again in the next class we'll revise. Again, I'll explain you, but today you just try to derive it with proper direction. What are the things clearly written in NCERT? Okay. Last step, Tanisha.
Yes, sir.
Last step, are you clear the mathematics?
Yes, sir.
This one, we have neglected A square, so R square to the power 3/2, it will become R cube. So this is the final expression for electric field. If this question asked in the exam, that board exam, that derive the expression for the electric field at a point P on the equatorial of a dipole, so you have to derive up to this equatorial line.
So they won't ask for axial one.
Yes, axial one also they will ask. Axial one we'll discuss in the next class. Okay.
Okay.
So you try to digest it first. Try to understand each step. Derive it at least 2 times these 2 days. Thursday we'll be meeting and we'll derive it and we'll solve some numericals also. Clear?
Okay,
So
sir.
dipole, just open it. Field, dipole, and the direction of the field. All these things you go through it. These 2 days. Tomorrow and Thursday. So Thursday evening, night, 9 o'clock, we'll be meeting.
Thank you, sir.
Any other question?
No, sir.
No, sir.
Okay. So I'll
Thank
share
you,
you
sir.
this note also.
Yes, sir.
So you just go through.